Hello everyone. This is a nice problem that I saw and I'd like to share with you. First of all, we will use tools from chapter 4, that is loops, to create a code for it. And then I'm going to refactor it using function. And of course, there is plenty of ways to solve this problem, and you can come up with an alternative way to do that. First of all, what is the problem? I want Python to be able to create this kind of patterns. The pattern is a square of some size. In this first case, it's 5 by 5. In the other case, it is 6 by 6. And besides the boundaries of the square, I also want two diagonals. So the x elements are also on the diagonals, and you can see that it's an interesting pattern. Okay. So first of all, we need to discuss our pattern. What is clear? It's clear that first and last row have x's in it. First and last column have x's in it. And somehow we need to describe our diagonals. Of course, the basic way to describe our diagonals, and for that matter, just describe exactly where to put an x. So first row and first column, put an x, second row and second column, put an x. And if you think about it all together, how can you describe this main diagonal elements? This is where the row number is the same as the column number. So in this case, I'm using Excel, so it's using letters A, B, C, D, and so on. But this is first, second, third, fourth, fifth column. So when row number is equal to column number, that is my main diagonal. That's where the x's go. And another place where the x's go is another diagonal. And we need to come up with some numeric pattern to describe this diagonal. If you think about the row number and the column number, so row 1, column 5, and row 2, column 4, and so on, row 3, column 3, you can notice that the sum of the row number and column number is always 6 in my first example. That is the size of the square plus 1. So before long, you can understand that this is the pattern we want to be working with. Row number plus column number equals to size of square plus 1. So basically, I described everywhere where I need to put x's, and in all other places, I don't need to put x's. All right, so the way we're going to do this problem, we are going to use printing statements to print each of the x's, then advance to the new line, and then print x's where we need them. Okay, so I chose two absolute constants here, symbol that we are going to put in some of the squares, and the overall size of the square. So we are going to iterate through the row numbers and column numbers in some sort of order. So I think I'm going to choose to iterate through the row numbers, because that's how printing statement will naturally go. So we write things horizontally, and that's how the printing statement is designed. Okay, so first of all, let's take care of the first row. And I'm going to use a loop, even though there is another way to do it. Feel free to do things differently. For j, this is how we enumerate the columns in range 5. I'm going to print symbol. Sorry, capitalized. And that will create 5 consecutive symbols, x's, horizontally, but only if I use a modifier. For the end, I'm using nothing instead of a new one. So that creates the first line of x's. And then I also print nothing in order to advance to the new line, because the default end of the line symbol is new line. All right, and I can also do a similar thing for the last row. Let me comment first row and copy paste for the last row. Gonna do exactly the same. Print symbol, and this will be last row, and everything interesting will happen in between. So now for all the remaining rows, let me switch here and I'll try to highlight them for you. I will need to describe where to put my X's and where not to put my X's, that is blank spaces. So first of all, in the very first time around, I put an X. Last time around, I put an X. And in between, I'm going to put an X depending on condition. It may be a good idea to think what this condition will be. If we are on the main diagonal, we are going to do that when row number is equal to column number. Okay. So first of all, I'm going to iterate through the columns, through the rows. For I, that is the row for I in range, think what my range should be. So this was I equals to 1, 2, 3, 4. So it should be from 2 and to size. So this is how I'm going, where I'm going to handle every row in the middle. Printing middle rows here. Okay. Now this is an index for the row. I need another index for the columns, J, in also range from 2 to size. And here is printing. So for every fixed I, I'm gonna run through the J's, meaning for every fixed row, I'm gonna run through the columns. Like I fix row 3 here and I run through the middle column. So here I print nothing, here I print X, and here I print nothing. So what I print depends on the combination of I and J. So go back to our conditions. When do I place my X? When, for example, on the main diagonal, row number is equal to column number, I was a row number, J equals to is a column number. So here we go. I'm going to do an if statement. If I equals to J, I'm going to print symbol, and end will be nothing. Else print I'll just do a single here, single blank space, and end should be nothing. Question to you, will this work? So honestly, I have second thoughts about whether I need to go all the way to the size. I think I need to go to size -1. So for 5 by 5 square, I need to go 2, 3, 4. And that's what actually, since the way the range works, the range doesn't work till size, it goes to size -1. Okay, so that works. And one more thing that I need to do, I need to begin every row with actual symbol. And I need to end every row also with a symbol. But my end of the line should be the default new line because I want at this point to advance to the new line. All right, so this is my code. Sorry, I should have size here. And where is my last row? I should have size here as well, not 5. And let me run this and see what it does. So it does look a little bit compressed here. I think we're missing how many? 2 blank spaces. Yeah. So I think I have a little bit more than I need. In the first row, let me change size to something a little bit more symmetric, like star. So maybe that will make it prettier. So here we're skipping 2. And here we're skipping 2, but because they are blank, okay, we'll cheat here to make it look prettier. So I had to do a double space. All right, so we have one of the diagonals, we don't have the other diagonal. How do we do the other diagonal here? The other diagonal, row number plus column number equals to size of square plus 1. Okay, so if I equals to j, or another condition, I plus j plus 1, I plus j equals to size plus 1. Let's rerun. Double equality. Run. Let me rerun it from scratch. Here we go. So this certainly works for 5 rows and columns. And we want to change it, for example, for 8. Rerun. Works just as well. You might find some way to do some beautification, and that is okay too. What I'm going to do, I'm going to make it a little bit more interactive. So right now, I'm as a programmer able to go to the symbol and change it to anything else I like. For example, let's put zeros here, rerun, and get new kind of pattern here. And this is kind of a part of the code, and that's the inconvenience of it. That's why we don't necessarily want to do it. Okay, so what I'm going to do now, I'm going to take the same code and I'm going to organize it as a function. So press tab, indent, and I'm going to say this is a function, def. I'll call it square. Let's say and diagonals. And my parameters for now will be size and symbol. And my function will stay the same for consistency. Now this will be no longer constants. Let me just comment this out. And I'll do replace capital size with small size. I'd say replace all. And also Control H for, I think, replacing symbol for symbol. Replace all. I think I have to redo it and oh, sorry, I'm trying to do it in a selection instead of everywhere. More serious programming environments are actually better for this kind of editing, but they take a little bit longer to learn. Okay, I see what's happening. So replace all. Okay. So now we have small size and symbol everywhere, and how can we use it now? Run. And I can call from here square and diagonals. Size and symbol. Size will be 7 and symbol will be 5. Actually, it has to be a letter, so just to make sure it works. And indeed it works. So we are, first of all, now we can call this function from any other function or from any other project we want. And second, it becomes more interactive. So I can call it and then I can define parameters for it to run with, so 10 and all. That has to be a symbol. Okay, you get the idea. And there are further improvements possible. For example, you can have one kind of symbols on the boundary and another kind of symbol for diagonals. The only thing you need to decide whether the corner is boundary or diagonal, but you can quickly change that. So that's probably all, where I want to stop now.